Previously, I'm explaining about the model of a backpropagation neural network using a usual Python like libraries of pandas, scikit-learn, NumPy for creating the models. And this time I'm going to use Keras or Tensorflow, because the Tensorflow and Keras is quite relevant for creating effective and highly recommended libraries for creating machine learning. So TensorFlow is like one of the, instead of a PyTorch, it's like we call it another ways to create a neural network, like convolutional neural network or reluctant neural network. So but this time I'm going to creating it, and by importing the clean data set which contain a header. So I'm just using a column of a 1 octanole, which it will be as a target. So the other columns will be the data. So I'm going to split the trend and test size. So test size is equal to 0.2. Also, of course, a training set, the size is 0.8. So I'm going to use a call it Keras coding, and this is the format of the Keras. So the first, the input layer is about 14 nodes, 14 neurons, and for a hidden layer is 25, and output layer is 1. So I'm using ReLU activations, and for the output layer is sigmoid activation functions. This is actually these two is kindly different. Recommended for ReLU compared to sigmoid. So I'm going to using a model of optimizer, Adam, and loss, MSE, and matrix accuracy. So I'm going to set up about a epochs 500 and batch size 32. So it's quite recommended for a batch size of 32. So maybe the iteration become a 15. So alright then, so this is the result, and I just got the accuracy of 100% accuracy. Before this is just about 0.87 and improving, and finally meet the high accuracy ever. And this is the graph for training and validation loss and training and validation accuracy for every one epoch, per epochs. So and it's a decreasing, the loss is increasing, and while the accuracy is keep increasing, loss is decreasing, keep decreasing, while accuracy is keep increasing, right? So just a short and just a simple ways of coding for neural network, but it's not quite really explain about backpropagations. It's not show the activation function, the calculations for updating the weight, and also for the step, like a step 3, step 4. Yeah, it's not shows the calculation, but actually Keras is not like the old ones that I code before this. The usual Python, they have to show up how to propagate the error and store in neurons and calculate the derivative, and so many you have to code for creating the model, also the calculate accuracy percentage. But I just, for Keras, it's simple, and it's just a simplify your coding. You doesn't have to create the calculations, so on. So that's all for the neural network using Keras. Thanks for watching.